We're starting a new section, and that is on applications of linear equations. And our goal in this section is to be able to write the equation of a line given certain information. Before we get into the process to do that, let's review some of the important formulas that we have learned about lines. One is the slope formula. Remember that is the formula m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And we also know the standard form of a line, that is the equation ax plus by equals c, where both a and b are not 0. And then we also know the slope-intercept form of a line, y equals mx plus b, where m is the slope and b is the y-coordinate of the y-intercept. We're going to learn one more form of a line, and that is called the point-slope form. And it is given this, that if x sub 1, y sub 1 is a point on a line with slope m, then the point slope form is given by y minus y sub 1 equals m times x minus x sub 1. This formula actually is derived from the slope formula. Recall that m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So if x1, y1 is a known point on the line, and then xy represents any point on the line, then the slope formula becomes m is equal to y minus y sub 1 divided by x minus x sub 1. And then we can cross multiply to get y minus y sub 1 is equal to m times x minus x sub 1. Right, cross multiplication, if you have two fractions set equal to each other, you can cross multiply. That is equivalent to multiplying each side by the least common denominator. But this form is nothing more than a variation of the slope formula. So let's look at how we can use this to write equations of lines. And we, in example 1, want to write the linear function that satisfies a given criteria. Recall that a linear function is a form f of x equals mx plus b. And f of x is just y. So that is, we want to write our final answer in slope-intercept form and then function notation. We have a line that passes through the point negative 1, 3 and has slope negative 2. So we have a slope m equals negative 2. We have a given point x sub 1, y sub 1, which is negative 1, 3. So knowing a point and a slope, we substitute into the point slope form y minus y sub 1 equals m times x minus x sub 1. Substituting, we get y minus 3 is equal to negative 2 times x minus negative 1. So we put the negative 1 in parentheses. Simplifying, we get y minus 3 is equal to negative 2 times, in parentheses, x plus 1. Now we can distribute on the right to get y minus 3 equals negative 2x minus 2. Then, to solve for y, we will add 3 to each side. So y is equal to negative 2x plus 1. In function notation, we get f of x is equal to negative 2x plus 1. Now we can see right away our slope is a coefficient of x, which is negative 2. We also need to check by confirming that the point negative 1, 3 satisfies this equation. So that means if we find f of negative 1, which is negative 2 times negative 1 plus 1, or 2 plus 1, we get 3. And that's exactly what the y value should be when the input is negative 1. So our linear function is correct. Now you may have learned an alternate way to write the equation of a line that doesn't even use the point slope form, and you can certainly use that if you're comfortable with that. That is, I could use just the slope-intercept form. That is y equals mx plus b. And the problem is that the point I'm given is not the y-intercept, so I don't know b. But I do know an x and y and m. So we could plug in place of y is 3 equals, m is negative 2, x is negative 1, and then plus b. So we get 3 is equal to 2 plus b. And then when we subtract 2 from each side, we find that 1 is equal to b. So now we know the value of b, we know the value of m, so therefore y is equal to negative 2x plus 1, which is what we found with the point-slope form. So either way is correct. Example B is the line passes through the points negative 3, negative 2, and 3, 6. So the problem with this is that we know 2 points on the line, but to be able to write the equation of the line, we need to know a slope. So step 1 in this process, if you're not given the slope, is to find the slope using the slope formula. So we know that x sub 1, y sub 1 is our negative 3, negative 2, and x sub 2, y sub 2 is equal to 3, 6. So we find the slope formula by substituting into m equals y sub 2 minus y sub 1 divided by the expression x sub 2 minus x sub 1, which in this case would be 6 minus negative 2 divided by 3 minus negative 3. The numerator is 6 plus 2, or 8, divided by 3 plus 3, or 6, and that simplifies to be 4/3. So now we know a slope, and we know 2 points, but at this point I only need to worry about 1 point. So if our slope is 4/3, and let's just choose the point 3, 6 since it doesn't have any negative values, and we're going to plug into the point slope form. So y minus y sub 1 equals m times x minus x sub 1. So this time our 3, 6 is our x sub 1, y sub 1. We get therefore y minus 6, right, is equal to 4/3 times, in parentheses, x minus the x1 value, which is 3. Now our goal is to write this in this slope-intercept form, which means to solve for y. We will first distribute on the right, so 4/3 times x is 4/3 x. And then 4/3 times 3 is just going to be 4, right? If you need to write that out, 3 goes into 3 one time, and 1 times 4 is 4. So we get 4/3 x minus 4 on the right, and then we can add 6 to each side. So y is equal to 4/3 x plus 2. In function notation, we get f of x is equal to 4/3 x plus 2. Now we can check our function. It should be that negative 3, negative 2, and 3, 6 satisfy this equation. If we find f of negative 3, we get 4/3 times negative 3 plus 2, which is, what, negative 4 plus 2, or negative 2, so that checks. F of 3 is 4/3 times 3 plus 2, which is just 4 plus 2, or 6, so that checks. So our work is correct. You can also substitute this equation into your calculator and look at the table, and you should see that these 2 points are in your table of solutions as another way to check, or graph it and see that those 2 points are on the line. Part C is given to us in function notation. We're told that f of 2 is equal to 7 and f of negative 1 is equal to negative 2. Remember that this really represents ordered pairs. Our ordered pairs are 2, 7, and -1, -2. So here again we have a case where we do not know the slope of the line, but we know 2 points on the line, which enables us to find the slope. So if we let x sub 1, y sub 1 equal the point 2, 7, and x sub 2, y sub 2 is equal to the point -1, -2, we substitute into the slope formula y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Substituting gives us -2 minus 7 divided by -1 minus 2. This is -9 divided by -3, or just simply 3. So now I know the slope in 2 points. My second step is to use the slope of 3 together with one of those points. And again, I'm going to choose the 2, 7, since it doesn't have any negative signs. And sometimes you don't have that option. You can work with the negative signs. It's not a problem. But if we let x1, y1 equal 2, 7 and slope 3, we get into y minus y sub 1 is equal to m times x minus x sub 1. We have y minus 7 is equal to 3 times x minus 2. Distributing on the right, we get y minus 7 is equal to 3x minus 6. And we can add 7 to each side to get y is equal to 3x plus 1. So in function notation, we get f of x equals 3x plus 1. And to check, we find f of 2 and make sure that it is 7. So f of 2 is 3 times 2 plus 1, which is 6 plus 1, or 7. And then f of -1 is 3 times -1 plus 1, which is -3 plus 1, or -2. So our function values check out. Now, the last two examples will be special cases of lines. Part D has a line that passes through the point -3, 5 and has slope m equals 0. Now here we actually know a slope and we know a point, so we could just immediately plug into the slope formula, the point slope form, to get m is equal to 0, our x1, y1 is -3, 5. So y minus y sub 1 equals m times x minus x sub 1, gives us y minus 5 is equal to the slope 0 times x minus -3. But note that on the right-hand side, 0 times anything is just 0. This equation simplifies to be y minus 5 equals 0, or y is equal to 5. So in function notation, f of x is equal to 5. Now, could we have known that just by observation? And we could. Remember that when the slope is 0, that corresponds to a horizontal line, right? The 0, horizontal. Horizontal line is always of the form y equals some number, and it's always the y value of the point. So just from looking, we could have known that this equation is going to be of the form y equals some number, and that is y equals 5. This is an example of a constant function, if you recall. Right, the y value is 5 regardless of the x value. E says a line passes through -3, 5 and has undefined slope. With this problem, there is no slope that I can plug into the point slope form, so I need to use my brain to think about, well, what does this mean? And remember that undefined slope, if you remember the UV An undefined slope corresponds to a line that is a vertical line. And a vertical line is always of the form x equals a number, and it is x equals the x value of the point that you're given. So for a vertical line to go through negative 3, 5, the equation will be x equals negative 3. Now there's no way I can write that in function notation because x equals negative 3, which is this vertical line through negative 3 on the x-axis, fails the vertical line test, and it is not a function. So my answer, though, would just be x equals negative 3.